Okay, so welcome everybody. Yeah, now this is the talk. You can pay attention. Okay. Well, this is what is this? Continuous deployment of OpenStack of OpenEDX with OpenStack.
Yeah, a bit there too.
Oh yeah, I can check it out over there. Okay, cool. So, is this how it works?
Yes.
Yeah. My name is Adolfo Brandis. I work for Hastexo, and we're a OpenStack / OpenEDX shop. Okay, and this is Xavier from OpenCraft, and this is an interesting situation because we've worked together before on a completely different open source project, and it's been an interesting opportunity to try and do this again, right?
Yeah.
So, Xavier?
We seem to be able to choose good projects because it was really unrelated, and we ended up working on OpenEDX also together. So
yeah. It's a coincidence, a good one. Okay.
So
yeah.
So the like the title of the talk is pretty much a mouthful: continuous deployment of OpenEDX with instance with OpenStack. So we'll try to go slowly through the concepts, introducing them one by one. The first part of the talk, Adolfo is going to be talking about OpenStack, what it is concretely, how it's an alternative to AWS, and the state of its support in OpenEDX. Then I will introduce deployment of OpenEDX instance with Ansible. So in the more general case, whenever you use AWS or OpenStack, so kind of the best practices for both. And then Adolfo will resume and talk more specifically about deployment of OpenEDX with OpenStack. And then I will try to talk about how we can let the robots take care of everything and just do nothing the whole day, or more precisely how to finish automating the rest so that an OpenEDX instance can be deployed from the beginning to the end without manual intervention.
All right, so what's all the hoopla with OpenStack? What is OpenStack? How many of you have actually used OpenStack before? All right, that's a decent percentage. How many do most of you know what it is at least? Well, probably a little bit, right? Otherwise you wouldn't be here. So OpenStack is, how about you click the slides and I do it for you when it's your turn, right? It's a little situation here where the computer with the slides over there. Sorry. Anyway, what is all the hoopla with OpenStack? Here? Okay, there you go. OpenStack is an open source cloud computing platform, much like, it's a cloud platform much in the same sense as AWS is, okay? Amazon AWS, you probably all know what that is, all right? A lot of OpenStack was even modeled after AWS, okay? So that's what it is. A big difference, though, is that OpenStack is open source. So you can take it and install it on your own hardware if you want to, okay? You wouldn't usually want to do that, right, if you're sane, but still, you can pay people to do that for you, right? Why OpenStack then, as opposed to AWS? What's the big deal? As you probably realize, having just one vendor provide something to you in the whole world is not very good. Well, it's not very good, period, right? You want to have more than one option if you have a fight with that vendor and you want to go somewhere else. Where do you go? Okay, or let's say that vendor goes insane and starts charging a lot of money, and so on and so forth, right? So you want more than one vendor. And OpenStack gives you that in the sense that OpenStack itself isn't a vendor, but several vendors implement OpenStack. So let's say you write an application that uses OpenStack. You can then move from one OpenStack vendor to another. Okay? So that's a huge advantage for certain kinds of businesses. And of course, it's open source, so you can see what's going on behind the scenes, right? So how many vendors are there actually in OpenStack land? This is from the OpenStack Marketplace website. And this is just the northeastern United States and Canada. Okay, so there are dozens at least in the world right now. There's even one in Brazil, where I'm from, in the middle of the jungle, right? Except we killed all the jungle, so it's no longer a jungle. Right? There are even plenty of clouds in Europe to choose from, Asia, etc. So there are many options. Now, when we want to compare OpenStack with AWS, it's a tough job. But if we limit ourselves to what OpenEdX needs from OpenStack, it's pretty much a simple list, right? Can you upload static content? Can you create networks? Can you launch VMs? Everything that OpenEdX needs, you can do with OpenStack, right? It's not a limitation in any sense of the term, okay? And now Xavier is going to explain a little bit of how you deploy OpenEdX in general, right?
Yes. So before delving more into the OpenStack specifics, there are a few best practices that are common to also AWS that is not necessarily followed by every instance. So it was an interesting recap to start with. The first thing that you do within the cloud is that you'll be instantiating a VM. So that will just be a standard server where you'll have Ubuntu on it, just like freshly installed. And what you do in that, you run Ansible on it. So like basically the steps that you would do normally, manually going to the server, connecting by SSH, installing the packages, and etc. All of that is described as some kind of a recipe called the playbooks and roles in Ansible. And that gets you to have Ansible doing it for you automatically and having a pretty standard setup once it has finished running. So the thing is that you still do that by typing line of code. So there is a part that is manual, that is not always completely easy, but we'll come back to that later. But mainly you would clone the source code from the OpenEdX project, all the recipe for Ansible, and you run it with your specific configuration, because obviously even if the way to install it will be the same on all instances, the name of the instance or the email users will be writing to, all of that will differ. And that's how you pass those parameters to Ansible so that it configures the server accordingly. And obviously, that's just on one server. And one of the great advantages of using Ansible is that if for whatever reason you need more than one server, you can just clone them and have like as many OpenEdX server as you want. And if for whatever reason one of the servers breaks down or is killed, you don't have to find a Jedi and spend 20 years to train it. You can just get a new one and you can get on with it. So if we come back to the servers, let's say your server is broken, the VM is down. The way you would go at it, a little bit naively in this case, is that you would instantiate a second server, run the same set of Ansible script on it, and that would give you the new server, and ta-da, you have it like before. So it's the idea that you don't rely on any one VM because they can always fail, hardware is feeble, and you want just to have a reliable way of redoing the same work without spending another week on it. So once you have done this, it's good to know that on your VM, there is actually a little problem with what I explained right before, is that on your virtual machine, you will have data, so like the user account, the courses, and etc. So if that is destroyed, obviously, your users are not going to be very happy. So the way you deal with that is that you make sure that your data is actually stored outside of the virtual machine in a separate database. So MySQL, MongoDB, MySQL for the user data, MongoDB for the courses in a simplified way. This way, you also have the same thing for document storage. So that's user uploads, images, etc. So it's basically another type of database. So it's also state that you want to get out of your virtual machine. So on AWS, it's S3. On OpenStack, is Swift. So how it really works for the use case that I was giving before is that when this server breaks down, you still have your database on the side, and you can create a new VM, connect it to the database, and ta-da, you have exactly the same thing with still your user data available. So you didn't even have to take any backups or anything, and this can be done very quickly. Also, how does this applies to deployment of a new version or replacing new servers? So let's say you have one VM, all your users are using that one. You want to deploy new version, I don't know, Eucalyptus has just been released, or you want to push a new change. You will be creating another VM, different one than the one that your users are accessing right now, and run Ansible on it, put the new version there. And this way, while it's running, your user can still access the website. And whenever you're ready, you'll just redirect your users from the old VM to the new one and just get rid of the old VM.
And that almost never fails.
Yes.
Right?
Well, if you that's the thing. If you do it really from a clean VM, basically without building on top of the same VM over and over, you have actually much less chance of failure than if you just try to cram everything always on the same server.
This is what edX.org does, right?
That we have shown in a simplified way, yes, it is.
I'm now going to start the discussion of how one would deploy using those principles on OpenStack itself. Okay, and the first question is, as opposed to AWS, on OpenStack you have two choices of general types of cloud to deploy to, a public cloud or a private cloud. A public OpenStack cloud is pretty much like AWS. Okay, so you pick a vendor, let's say Rackspace, and you buy a VM or 2 or 10 or 100, and you pay for their use, okay, and you deploy there. If you tear them down, you're no longer paying, and so on and so forth, much like AWS. However, sometimes it makes more sense to deploy to your own hardware or to hardware that you know isn't being shared with anybody else, right? So if you use Amazon or a public OpenStack cloud, you have a VM or 2, and you don't know who else is there in the same hardware as you are, right? And that may not be something you can live with. Maybe it's a government regulation. Maybe it's maybe you're just paranoid, right? So you want your own hardware. And when you want that, you use a private OpenStack cloud. And that's really cool, because you can either do it yourself, or you can, as I said, pay somebody to go and deploy OpenStack for you, okay? Even Rackspace, I think, does that. So public or private, that's the first decision.
And then to show you how that looks like quickly when you do things. So if you're familiar with AWS, that's the equivalent of the AWS console. So that's how you create a new VM in OpenStack. You have pretty similar type of options where you choose the size, the amount of RAM, hard drive, and etc., the operating system, and etc. So that's still kind of a manual step that you do in a visual, in a UI, in a web interface. So, like, if we come back just quickly to that step from earlier, like I said, creating the virtual machine was a manual step. Running Ansible also is a manual step, because you have to clone the configuration, run it from your command line, and you obviously have to do that every time you want a new virtual machine. So all of that is actually manual steps that you have to do every deployment or every new instance, or when you want to scale. So what we would like to have, ideally, is just replace all of that with a big button. I deploy, and there is a robot that takes care of creating the virtual machine, of running Ansible, of doing everything like that for us, just to make sure that deployment becomes something that you do in a few minutes, maybe an hour or two with the run itself, and not something that ends up taking 1 day or weeks in certain cases for upgrades. So there are various tools that allow to automate some of those steps. But some of them, there are like many more. It's really an area which is really active at the moment in DevOps. It's just some of them that are currently used for OpenEDX. So Terraform, that's from the people who do Vagrant. DevOps at edX has currently project of moving a lot of their architecture to that. The equivalent in a pure OpenStack would be HIT, that Adolfo is going to mention a little bit. edX has been using Alton, which is kind of a chatbot that automatically builds image for you, and then they have an equivalent for switching them. There is also a continuous deployment project at edX using GoCD, which allows to define like a deployment pipeline. Murano is the pure OpenStack option. Currently, there isn't much that exists with Murano, and it's something which is really specific to OpenStack. And also, you usually need to have your own private cloud because most of the public clouds don't have it. And there is also the solution that we are using internally and that we are currently like extending to allow other people to use it, opencraft.hosting. Which basically is our tooling for automating the setup, deployment, update of OpenEDX with OpenStack. So I'll show a little bit more also about that later. So here I'm going to pass it back to Adolfo, who is going to talk about HIT.
Yeah, so remember that nice little Horizon interface, the OpenStack manual provisioning? This is the automatic one, okay? So OpenStack HIT. HIT is the equivalent of Amazon's CloudFormation templates, if you know what those are. The idea is you take a single template, or it's in a text document. In this case, a JavaScript, a YAML document. And in that document, you define all your VMs, how they talk to each other, what code goes in them, and so on and so forth, right? And once you have that template, this is how you actually deploy it, okay? So yeah, it's ugly, it's the command line, but don't underestimate it, okay? This is what we actually use in production, okay? So we get customer requests to fire up environments. This is the command line we use for a new environment. Click, enter, that's it, okay? All right, if you want a sample actual template, the one that we actually use in production, that's it, okay? Let's leave that up for a few seconds if anybody cares. That's a regular HIT template that you can use on any OpenStack cloud whatsoever, okay? If you run that template, you get an edX environment, or at least one that's ready for edX deployment, and I'll get to that in a minute. All right? So if you run that template with that command line on an OpenStack cloud, this is what you get, roughly. I don't know how easy it is for you to see here, but you get a deploy node or a bastion node, whatever you want to call it, from which you're going to run the Ansible scripts Xavier mentioned earlier. Okay? And these Ansible scripts are going to connect to the backend nodes, the blue circular ones over there, cylindrical ones, and the app servers, the red, these guys over here. Okay? And what the Ansible scripts will do is they will deploy MySQL, or rather Galera, in a highly available fashion to the backend nodes, and MongoDB as well, to the same physical nodes, but to different hard drives, to different volumes, okay? So you can back those up independently. And then you get an arbitrary number of app servers, which makes this a scalable deployment. All right, so you can have one app server or 100 app servers, and in each app server, the Ansible scripts are going to deploy the LMS, the CMS, and whatever else edX needs. Okay, we didn't reinvent the wheel in any sense here. What we want to contribute, actually, it's up for in our queue to contribute, is just the HIT template and a few and something else I'm going to talk about in a minute. Okay. Also, something cool that OpenStack provides is in a load balancer as a service. So we're actually using that here. Instead of setting up a node with HA proxy or whatever you want to use, or Nginx, we use an OpenStack feature, which is a load balancer as a service, to direct users to the app servers transparently. Okay? So it's kind of neat. You should check it out if you're interested. Next slide. Okay. There's one problem with that, and it is, how do you tell the Ansible scripts what the app servers are? Okay, so if I can have 1 or 5 or 10 or 100, how do I know? How do I tell the scripts which of them are running and what their IP addresses are, right? So OpenStack provides a feature where in the heat template, you can insert metadata into the deployment itself so that, for instance, an Ansible script can query that data and find out about what are the different app servers, okay? So you needed something called a dynamic inventory generator to feed that data into Ansible. And that's a little bit of Python that shows you exactly how that's done. All right, I'm not going to go into too much detail, but essentially, the script just fetches metadata in JSON format from a fixed URL. It's always the same on any heat stack or any OpenStack deployment. And from there, it gets the data needed to find out what the app servers are. This is also part of our intended contribution to edX configuration, right? This is up on our public Git repo as well. Okay, so how about you have that neat little cluster running on OpenStack using heat, and you want to add a new VM or 10. What you do is you run that exact same command line I showed you before, but with a different app count, right? So what it'll do is create the necessary number of VMs, or if you're reducing the app count, it'll delete some VMs for you and reconfigure the load balancer accordingly, right? So it's pretty transparent as well. However, you still have to run the Ansible playbooks manually on the new VMs if you have any. Okay? Next, and now back to you.
Mm-hmm. So while we are still in terms of creating a new setup, which is one of the main advantages of Heat, just to show a little bit the equivalent for OpenCraft hosting. So that's actually how you create a virtual machine. So you can see that the focus is a little bit different. We try to be more in terms of the end user, or someone who would want to set up their own instance. So that's what you would see at the URL of the beta test registration that we have at the moment, so opencraft.com/hosting. So you basically just put the domain name that you want, the instance name, and then it will create the VM. So it will know about all the rest, running the Ansible script, bringing up the right resources from OpenStack, and etc. And I'll show actually a little bit more about what you do after that, which is one of the key aspects of this talk, which is the continuous deployment. So why all of that tooling? It seems like a lot of things to do just to automate some steps that you could be just wanting to do anyway. One of the main advantages is that the time that you gain in deploying an update, you can use it to deploy your updates much more often. And the principle of continuous deployment is that it will be as often as you merge. So anytime you add a new feature, or anytime there is a new patch, a new version, and etc., immediately, as soon as it's merged, you can have it on the live production servers. So to show some tools that are used, at least partially in that area, so some of the ones that I was mentioning in the slide previously. So that's Alton, so that's a log of a chat on edX internal chat channel, where there is a request on top for him to provision a new AMI, so that's on AWS, and to build it so that runs Ansible, that makes it ready, and then afterwards it's ready to create a new VM with it and switch it on the live server. This is how edX.org is deployed at the moment, by the way. So another one that I mentioned, which is also coming from edX, the continuous deployment pipeline with GOCD that they are currently working on. So still with this goal in mind to be able to deploy updates much more frequently. Currently they do it once a week, and it's usually a big mess. Someone has to spend 1-2 days running after people just to get it running. the idea is that they would use that to just have individual developers pushing their changes. And last but not least, the one that we are using, that we've been using to deploy our sandboxes for over a year now, and that we are deploying on our production instance now, and still the same goal as what I just mentioned, the idea that whenever we do a change for a client, the client will want to have it deployed pretty quickly. So just having the ability of pressing a button instead of spending several hours trying to figure out what code where and deploying it, that would gain us a lot of time, and that would also make it cheaper for the clients. So I had planned originally to do a full demo, but given the setups here where the computer is actually over there, I replaced it by a screenshot, but I promise I didn't doctor the screenshot. Yeah, well, you can try the project and see it for yourself if you want. So we'll take a very simple pull request to just illustrate that workflow that I was mentioning. So that's a very bare bone OpenEDX site. That's what you get when you just run the default set of playbook, when you haven't customized it or anything. And that's how that instance looks like when it's provisioned within the instance manager. So it's a little bit small, but basically you see here a list of the instance that we have. Here it's the current VM or version of that site which is provisioned, and here that's like its current status, the logs, the configuration details, and etc. So that's all handled directly by the instance manager. We just had to fill that form that I was showing before, and then I created that. So here is a change that we would like to get on our server. So that's a pull request against the version of the code that we have asked the OpenCraft hosting to deploy. Basically, it's really simple. It just adds a section in the menu on the top. So if we come back to it, where you see register, we just add right next to it, host your own instance with the link to make our own advertisement. So that's what we want. We have the pull request, and now how do we get it live? That's the part that usually takes a while. So the idea here is that once it's merged, so I've just merged the pull request, we'll just go to the interface, click launch a new app server. So I'll just say, okay, take the latest version of the code and rebuild everything. So that will create a second instance. So the first one is still active. So like I was showing in the initial set of slides, the users are still being directed to the previous one while it's provisioning, so they still don't see anything of the new version. Once it's done, in one of the sections, I'll click activate this app server, and that will start redirecting users from the old VM to the new one. And then if we go back on the URL that we were before, if we refresh, ta-da, we get the new link that appears. So that becomes something that was really like you need to involve DevOps and schedule tasks and whatever. That becomes like something that you can click your way around in 5 minutes. So that's it for the presentation. So now we have a little bit of time for questions, I think about 10 minutes. So if you have anything you'd like to know. Yeah.
I have some kind of side question regarding deployment. Let's say I have an instance, but I want to allocate limited resources because I know that most MOOCs are closed, and maybe 2 days later they will all open, and then I need new instances.
Mm-hmm.
And maybe I have 3 instances, but for one, the forum, let's say, is buggy.
Mm-hmm.
In your process, is there a way to know that one instance is overloaded or one part of the software is buggy, and then you will know that you have to deploy something?
You mean failover, basically?
Well, generalized failover.
Well, currently there is monitoring, but there is nothing automated to switch from one to the next. Actually, that would likely be something that comes when we add support for multi-VM, because right now that only supports a single VM. We start small and because a lot of our clients just need that, and progressively we'll move to a client who needs more scalable infrastructure. And in that case, when you start to have for each of the services, multiple instances of it, you get the possibility to not only say, okay, I need, like it's overloaded, so I need to switch from 1 to 3, so auto-scaling, but you can also detect, okay, the second one is having a problem, so we need to remove it, and I bring one new up. So it's not there right now, but it's definitely high on our list because that's something that we have to do all the time.
And if you're using Heat as we are, it's, take your pick of monitoring solutions, right? It's just VMs running Linux, and what we do is we're actually monitoring stuff manually right now. With a little bit, we intend to have centralized logging contributed as well soon. But as you've seen, if you're running the stuff on Heat, you're deploying new machines manually, and you're also removing machines manually. So you have to essentially know what you're doing. It's a more hands-on approach if you're doing that. Okay?
We've had some very good experience with OpenCraft, but there are two things that stand out. First, because OpenStack is so easily available, there are many providers that provide a service of more or less good quality.
Mm-hmm.
And also, the code base of OpenStack changes very quickly.
Mm-hmm.
And the services become compatible or incompatible. So what's your take on that? Is there a provider that you recommend? Did you suffer from that?
Well, it's certainly something we've been exposed to, definitely. Like, it's both an advantage and a disadvantage. Like you said, OpenStack is moving on pretty quickly, pretty fast. So far, we have been able to stay pretty much clear of that by using a very core set of features that are really used by a lot of people. So whenever there is something that is there on some cloud provider, but not others, we tend to be conservative and not use it, because then not only we'll have better support and avoid the incompatibilities from one version to the next, but also it means that we keep the advantage of being able to move from one provider to the next more easily. But definitely that can happen. Right now, the provider that we're using is OVH in France, who, like every OpenStack provider at the moment, has a little bit less reliability than AWS. But we compensate it on the other side by having it making it much more easy to replace the faulty instances, or at least the availability part is something that we can manage pretty quickly because of the automation that we got. And then it's mostly on our side for the incompatibilities, a question of just following what that provider is deploying, and again, being conservative about which feature we use.
We've been using Elastic's, I think it's Sweden or Finland, and City Cloud also in Europe, the latter of which we're actually helping, we're actually supporting them in their OpenStack deployment. So as Xavier said, and as you said, it's a moving target, right? And not all OpenStack vendors know what they're getting into. So there's always the question of when it comes time to upgrade their version of OpenStack, right? There's a new one every 6 months. And you usually, as a provider, it's a good idea to upgrade every 6 months because the new features are awesome, or the code base is more stable. So there are always good reasons to upgrade, but few of them actually do, because it's such a difficult job to do it in place. Not least of which, because you need more hardware to test the new release of OpenStack, and then you need to move people over to that new release. Okay, so it's a complicated situation. The thing I recommend you look for in a vendor is their track record in upgrading OpenStack, right? If they've never upgraded it at all since they started, that's not a good sign, right? Because then that means you're probably going to be stuck at that version for a long time. And that's one of the things we look for in the providers we shop around for.
Have you successfully deployed insights with Hadoop and other stuff to OpenStack?
Sorry?
Insights.
Insights.
Yeah.
Excellent question. Have you?
We haven't. We have this question a lot because actually on AWS it's one of the things we do the most often for a lot of clients, and there are some challenges from the fact that currently the deployment on AWS is very dependent on some service that you have to redeploy on your own. So you mentioned Hadoop, so that's one of them. So currently no. But keep asking this question because the more we get it, the higher it gets in the list. So yeah, it's pretty high already.
It's also on our, I'm not going to say bucket list because we're actually going to start working on it very soon. But one of the problems you guys actually solved, right, which was S3 support. So I think OpenCraft worked on supporting OpenStack Swift, which is the equivalent of S3, right? And you can tell them a little bit about that. What's the status?
Yeah, like we try to go step by step. So typically, our first step was to be sure that we could deploy a production instance with the base set of services. And the last part that was remaining was the support for S3. So that one of those two databases that I was showing, the one for the file uploads, and that was just supporting S3. So now with the Swift support was a pretty big chunk of work. And I would imagine that for Insights, that would also be fairly significant. But that's clearly like our list. We are moving from one to the next. Whenever we see something which is really Amazon specific, we add support for it.
Yeah, that's a recurring problem with deploying edX, and if you're not doing it on AWS, right? A lot of the stuff in edX configuration is based on AWS services.
So we have to change much of that because by the Russian law you have to use services from Russian service.
Yeah, so that's a very good point. So apparently Russia doesn't allow people to use AWS for certain things, right?
Yep. As a personal data.
Personal data, right? So we all need drop-in replacements for the AWS stuff, right? So that's as Xavier said, keep asking these questions because we want to get there. Right?
Yeah, and also like we will all of those services, we all try to do that as a community effort. So if you have use cases like you and you want to help porting some of them, we can always talk and try to do it together. For example, in Site, we know pretty well how to deploy it, so we could assist with a lot of things there if you want to help. Just let me know afterwards.
Any more questions? Nope.
Well, that's
all right.
Cool.
Yeah. Fist bump.
Yeah. Thank you very much.
Thank you.